I am Madam Gracious Kanzieni from Educare, Tanzania. Warmly welcome in our best media, Educare TZ, so you can proceed with our A-level tutorials. And my student, here we have our chemistry subject and our class level is Form 5. We are proceeding with the inorganic chemistry, and my student, we are in our periodic classification. So today we're going to discuss the new concept known as periodic trends in the ionization energy. So my student, you can see that from the beginning we try to look the issue of the ionization energy. Tumeangalia some of the factors which are related to the ionization energy, ambazo tulisema kwamba ionization energy can be measured by using the issue of the electronic configuration, atomic size, locality of the orbitals, the nuclear charge, a lot of factors. Na tumeziona zote, tumeona ile the trends across the period and down the group inavyokuwa. But finally now we have to look this periodic trend in the ionization energy. Periodic trend in the ionization energy. So general, the ionization energy, this one increase from left to right across the period. Hasa hapa tunakuja kuangalia ile general concept of the the ionization energy in the periodic trend. Kwa sababu kumbuka, we have to look in the periodic trend in the physical properties of the element. As our ionization energy is among of our physical property, now we have to look the general periodic trend now. So here generally tunasema kwamba the ionization energies increase from left to right across the period. Kwamba hii ionization energy huwa inaongezeka from left to right across the across the period. So you can see kutoka kwenye ile zile expectational element ambazo zilikuwa observed, kwa mfano magnesium, magnesium and aluminium, nitrogen, oxygen, phosphorus, sulfur, tuliona ni vice versa. So you can see that these ionization energies increase from left to right across the period. Why? Due to the increase in the effective nuclear charge, which hold the electrons tightly. As we move across the period from left to right, you can see that when we talk about the ionization energy, you can see that it tends to increase. Why? Because there is the increase or the large nuclear effective charge. So if there is large nuclear effective charge, it means that it will hold those molecule or electron tightly. Kwamba zitakuwa holded to the nuclear. So if we are holded to the nuclear, it's very difficult to remove them. So the energy which required to remove that electron will be higher. That's why tunasema kwamba the energy, ionization energies tend to increase now from left to right across the period, simply because there is large nuclear or effective nuclear charge which hold the electron tightly. That's the first overall, or the first general the trend or periodic trend in the ionization energy. That is for the period or across the period. So now how about in the group? When we consider the issue of the group, anasema kwamba the ionization energy ambayo sometimes inakuwa represented by this IES, ionization energies. Kwa hiyo sometimes hata usipoandika ile ionization energy yote ukaandika tu I with the capital letter E, this means that ionization energies. So the ionization energies decrease down the group, kwamba down the group tend to decrease. Why down the group the ionization energy decrease? You can see that due to the increase in the number of the shell. Kwamba down the group we count that energy levels, kwamba 1, 2, 3, 4 na kuendelea. So kama kuna increase in number of shell, therefore simply this ionization energy will decrease, and hence the electron distance from the nuclear, which lower the attractive of the electron. Kwamba kama zile shells zinaongezeka down the group, maana kwamba itapelekea ile distance kuongezeka. Asa distance itakapoongezeka ita affect ile effective nuclear charge, ambapo effective nuclear charge itakuwa ndogo. Ikishakuwa ndogo, maana kwamba zile electron kuwa holded au kuwa bonded tightly to be difficult. Therefore, you can see that the ionization energy tend to decrease. Maana kwamba the energy ambayo itatakiwa ku remove zile electron itafanyaje? Itapungua. Itapungua. That's why tunasema kwamba down the group the ionization energy decrease. Down the group the ionization energy decrease. So despite this general trend, sasa tukiachana na hii general trend ambayo tumeiona kwamba across the period the ionization energy tend to increase, lakini down the group ionization energy tend to decrease. Despite on that trend, anasema kwamba there is the large discrepancy in the ionization energies for the various elements in the periodic table. Kuna hiyo discrepancy. There is a large discrepancy in the ionization energies for the various elements in the periodic table. That's why utakuja kuona kwamba kule kwenye zile nitrogen and oxygen, magnesium and aluminium, it observed this scenario, ilikuwa observed not follow hii trend, lakini pia kulikuwa na phosphorus na sulfur and so forth. Okay, so now in the figure 1.4 it show a sketch of the first ionization energies against the atomic numbers. The first ionization energy against the atomic numbers. First ionization energies against the atomic numbers. So ina maana tutaenda kuona sketch, it's like a graph or it's like a diagram ambayo imekuwa plotted kulingana na hizi data za consideration of the first ionization energies but also with the atomic numbers. So the discrepancy in the trends of the ionization energies is observed between beryllium and boron and nitrogen. Beryllium and boron, nitrogen and oxygen in the period 2. Kwamba hii trends ilikuwa, hii discrepancy ilikuwa observed katika hizo element, beryllium and boron, lakini pia nitrogen and oxygen katika period ya pili. Mean that we are talking about the horizontal row, ile ya pili, ya kwanza, ya pili. So and between magnesium and aluminium and phosphorus and sulfur in period 3. Kwamba huyu phosphorus na sulfur kwenye period 3 and so forth. Kwa hiyo sasa hizi utakuja kuzisoma vizuri, hizi expressionality au hizi discrepancy kati ya magnesium na aluminium, phosphorus na sulfur, but also nitrogen and oxygen, but also there is beryllium and boron. So specifically tukishaona hiyo trend, tukishaona hii plot, tutaenda kuona the first one ambayo ni boron and beryllium and boron, then tutaenda kuona tena kuhusiana na hizi nyingine ambazo ni magnesium na aluminium, phosphorus na sulfur, lakini pia nitrogen and oxygen. So this is our plot now. This is our plot. As you see here, these are the first ionization energies, but at the horizontal here we have the atomic numbers. So once we plot the graph like this, mean that tunaweza tukasema kwamba this our plot is first ionization energy against the what? The atomic number. Ina maana ile vertical ndio ambayo tumeiplot against this one, the horizontal one or the x-axis ambayo ni atomic number. So this is our plot actual. As you see, atomic number hapa we assume this scale of 4, 8. Ina maana hapa tumeenda kwenye 4, the interval for the interval for 0 to 4, 4 to 8, 12, 16, 20, 24, 28. Kwa hiyo the scale here in the horizontal is 4. 1 centimeter is equal to 4, ambayo hii 4 itakuwa ina represent the atomic numbers. But you can see here in the first ionization energies. So as you see, the same scale. So you can see the ionization energy, the way the trend is. Unaona inaenda, inarudi. So this is due to the age of the period and and groups, kwa sababu tunajua kwamba kwa mfano hapa tuna hizi element, for instance mpaka hapa hapa tuna hydrogen, helium, tuna lithium, tuna beryllium, tuna boron, tuna carbon, tuna nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium. So you can see how the trend is. How you can see the trend is. This is because of the age of the period, but also the age of the group. So my students, this is our first session. Thank you. Now let us see the second session soon. Bye bye.